Hello everyone. In this video, we are going to talk about Zookeeper data model. Now, there is a lot of buzz and talk that Zookeeper helps in coordination. Zookeeper helps in scaling your system. In fact, I have made a video on the introduction to Zookeeper. Check out the video in the link. But how exactly? The thing is that Zookeeper has designed their system very intelligently. What they have done is they have designed their data model in a way that you can model any of your scaling problem statement in terms of Zookeeper and then use it. For example, if you want to solve the problem of configuration management, you can solve it with the help of this data model. If you want to solve the problem of leader election, you can again model your problem statement in terms of Zookeeper data model. So without much ado, let's quickly get started. This is how the Zookeeper data model looks like. The name they have given to the Zookeeper data model is namespace. And this namespace looks quite similar to the Unix file system. So you can see there is a root, which is /. Then there are subfolders like /zoo, /zookeeper. And then you can keep on creating the subfolders, etc. And these folders, they are called as nodes. So this is the root node, this is the left child, this is the right child, exactly like a tree. However, here you can have multiple child at each of the levels. And all of these nodes can store data and they have some of the properties. This is how the overall structure of the data model looks like. Now what we'll do is we'll zoom into one of the nodes and see what are the information which can be stored in one particular node. So each node is called a znode and they store a bunch of important properties. The one is data, just like the tree. You have a node and you can store a data in that particular node here as well. And then you have a path, which is /separated path. So you have a root node, which will have /, then you will have children, and you can keep on appending / and store more information. There's one important thing about the data node is that you can store maximum 1 MB of data. So you are not supposed to store very heavy data into the Zookeeper nodes. You are supposed to store very small amount of data. So that's why this limit is of 1 MB and the general recommendation is even more small. They have access control just like the Unix file system where you have each folders and subfolders and you can give the access control to each of the folders and subfolders. Likewise, you can give the access control. That is, you can give permission that this particular person is allowed to read the data of this node. This particular person is allowed to write the data of this node and maybe delete as well. So there are a bunch of access control which are given to each of the nodes. And they have a lot of statistics information as well, that what is the version number. So the moment you change the data of a file or you change the node, the version number changes. So this is how the znode overall looks like. Now let's talk about types of znode. So there are 3 types of znode, in fact 4 types. One is persistent, the other is ephemeral. These are the 2 categories. And then there is another category of sequential and non-sequential. So overall, you can have persistent sequential, persistence non-sequential, ephemeral sequential, and ephemeral non-sequential. So you can have basically 4 types of znodes, and these categories or the property of the znode can be only decided at the time of creation of the znode, and then they cannot be changed. So we'll try to understand each one of those one by one, and we'll also run the command on Zookeeper command line interface to see how it looks like. The first type of node is the persistent node. So as the name suggests, persistent node means the node which never gets deleted unless you actually go ahead and delete it. So as the definition says, it has a lifetime unless it is deleted. And it is useful for in storing the data that is highly accessible and available to all the components of the distributed system. Example, configuration. So you store a data and you want that data to be available to everyone and you don't want that data to be lost. So in such cases, you use persistent node. Let me open the terminal and show you how do we create a persistent node and what are the properties of it. Here you can see that I have launched a terminal. The command to start the Zookeeper server is simple. It is bin/zkserver.sh base start foreground. I have already talked about various methods to connect or start the Zookeeper server. You can check out the previous video. I will link the details in the description. However, for running on local on standalone mode, this is the way. So launching the Zookeeper server on my local, and you can see that the Zookeeper server has started. Now I'll go to the client and connect to my Zookeeper server, and then I'll run a bunch of commands. So to connect to the Zookeeper server on local, this is the command. And you can see I have been able to connect to the Zookeeper server. Now I will run a few commands. Remember, I have already talked that the Zookeeper data model is very similar to the Unix system. So the first command is ls and / is the root path. And you can see this is the default response which you will get when you configure the Zookeeper server. The node at the root node will be Zookeeper. Now let's create a node, and we will create a persistent node. So the command to create a persistent node is create, you give the path, and then you can give the data of this persistent node. So the command would be, so this is the data, create persistent node, that is the name of the node with path, and then you give the data, and then you can press enter, and you can see that the node got created. You can name it anything. Now if I do ls, you can see one extra node is now created. I can do something like get persistent node, and it will give me the data of that node. So till here, it's all clear that I created a node and then I am able to get the data. So this is the same node which we were talking about in that tree structure, that you can create a node and then you can create their children as well. Now let's see, if I disconnect my client to the Zookeeper server, will that node still exist or not? So let me press Ctrl C. And when I press Ctrl C, my client got disconnected from the Zookeeper server. Now I'll connect again. And you can see I got myself connected again. Now if I do ls, you can see my node still exists. My node still exists because it's a persistent node. Now I will show one more interesting property of the persistent node is that you cannot delete the persistent node unless all its children are deleted. So what I'm going to do is I will create a child of the persistent node. So the way you can create it is using the command create persistent node, and then all the paths will be relative to the root. So I can name it as child, and the second param is data. So you can see a child node got created. Now if I do ls, I will get this data. And if I do ls persistent node, I will get the children of the persistent node. Now if I try to delete the persistent node, the command to delete is again similar to the Unix system, delete persistent node. And you can see it will give me the error that the node is not empty. You cannot delete a node unless its all children are deleted. But if I delete the children and then I delete the parent, you can see the parent got deleted. So this is how the data model or the data structure of Zookeeper will look like. And this is how the persistent node will look like. Now we'll move on to the another category of node that is called as the ephemeral node. Ephemeral node is the type of node that gets deleted the moment the client that created that node disconnects from the Zookeeper server, or any of the authorized client delete it. So you create a node, and if you disconnect from the server, that node will get deleted. And this session end can happen due to the connection closing done by you deliberately, that you close that connection because you wanted to do it, or you crashed. So if the client crashed, then also the connection will close. So no matter you deliberately close it or the crash has happened, in both the cases, the deletes can happen. And the ephemeral node is not allowed to have children. So remember, in case of persistent node, you could have children, but the problem was around the deletion part. But here, since the deletion of the ephemeral node will be very frequent, and the Zookeeper developers didn't want to have such confusion that people create a child node and then figuring out where did the orphan node go because the parent got deleted. They didn't want to have such confusion. So they said that, hey, you can't have a child node. And this concept of ephemeral node will be very helpful. It will be very helpful in case of coordinating between the servers. We'll see how it is done in the coming videos. But now let's get started with the simple commands. So this is the terminal which we already connected to the Zookeeper server. Now we'll create a ephemeral node. The command to create ephemeral node is simple. Just add -e and then you can give the path and data. So this is how you can create an ephemeral node. Very simple. Just remember to give -e in the command. Now you can get the data. Getting the data is again straightforward, and you can get the data as well. If you try to create the child node of the ephemeral node, you will get the error. So let's say you create a child node. You can see that you will get error that ephemerals cannot have children. And now here is a magic which will happen. If I disconnect my client from the server, this node will go away. So if I press Ctrl C, I have now disconnected this client from the server. Now let's reconnect and see whether this ephemeral node exists or not. So I will connect to the server and then I will do ls, and you can see that the ephemeral node got deleted. So when your client disconnects from the server, there is a timeout which you can configure, and after that timeout of the session, the ephemeral node will get deleted. Now let's talk about the last type of node, that is the sequential node. So the sequential node is assigned a sequence number at the time of creation of the node, and that sequence number is in the monotonically increasing order. So you try to create a name called as sequential, it assigned you some number, and there is some padding also done of zeros. This sequence number is maintained by the parent node. So if you create a parent node and then within that parent node, you keep on creating the children, each child will keep on appending this 1, 2, 3, 4, etc. So this will help you in ordering and sequencing and creating a queue so that you know which one got created first, which node got created second, etc. So it helps in that. Let me create a node to show you how it looks like. So I'll again go to my terminal and I will create my sequential node. So first of all, I'll create a root node, and you can see a root node got created. Now I will create sequential node within that root node, and you can see the sequential node SEQ001 got created. Now if I create another sequential node, let's say, and you can see now the number 2 is allocated. So you can keep on creating the new nodes under the node called as root, and the new sequence number will keep on getting assigned to the new node getting created. So if I put even my name here, I will be assigned sequence number 3. You can see I am assigned the sequence number 3. So it will help you in having the monotonically increasing sequence number. If there are multiple systems running and they are racing against each other, that who has better rank, then they can all create the sequential nodes with the same name, and the one which has rank 1 will be the first one, one which has the number 2 will be the second one, and so on. So this is how you can create the sequential node. You can also create a combination of ephemeral and sequential node. To do that, all you need to do is to give two commands, -s and -e, and it will take care of both. So if I run this, the node number 4 would have both the properties. It will be sequential and it will be ephemeral. If you do not give -e, then it will assume it to be persistent. So this is how you can create all 4 categories. You can have both the flags, then it will be sequential and ephemeral. If you do not have -s, then it will not be sequential. And if you do not have -e, then it will not be ephemeral, effectively persistent. So overall, you can have 4 categories, which I mentioned in the beginning of the lecture. Thanks for watching this video. I hope this video was helpful to you. In this video, we focus on the various types of Zookeeper nodes, that is ephemeral node, persistent node, and the sequential node. This will be the baseline for modeling various types of problem statements which Zookeeper solves. In the next video, we are going to talk about Zookeeper watches. That is, you can register a callback on the events of the Zookeeper node. That if any of the child has changed, then you can register a callback. So such kinds of thing we are going to see in the next video. Once you do that, you will be ready for the problem statements. My plan is to have some of the programming concepts of Zookeeper using Java. So the things which we have been doing using the command line, we will do the same using the Java language. That will be a small introduction. And once we do that, we are able to create node, delete node, update node, and we are able to register the callbacks. Then we will be definitely ready for the various types of problem statements. So that's the overall plan. I hope you like the video. Till the next time, bye.